Now let's talk about critical numbers. Let's define what they are. Suppose f is defined at c. If f prime of c is 0, or if it's not differentiable at c, then we're going to define this to be a critical number. So there are two things you have to check. First, is the derivative 0? Or second, does the derivative simply not exist? Now here is an example when the derivative doesn't exist. The left derivative does not equal the right derivative, so it doesn't exist here. So c is a critical number. Now right here, the first derivative is 0, and you have this horizontal tangent. This is something we'll cover over and over again. At this point, f prime of c is 0. So c is again a critical number. Now I want you to remember, critical numbers are x values. So let's look at this problem here. Let's see if we can find the critical numbers of f of x equals x cubed minus 3x squared. So f, let's take the derivative of this. This is 3x squared minus 6x. Let me factor this. I'm going to factor 3x out. Here's f prime of x. And we'll see f prime equals 0 when one of the factors equals 0. So when 3x equals 0, or x equals 0, or when x minus 2 equals 0, or x equals 2. And lo and behold, I have a critical number here at x equals 0 and a critical number at x equals 2. Now the relative extrema, it turns out, can occur only at critical numbers. So if f has a relative max or relative min at x equals c, then c is a critical number. Now remember, what does this mean? 1, the first derivative equals 0, or 2, f prime does not exist.